IOT Impact. So, already we have studied about the evolution of IoT. As the span of time increases, the usability of the user had a, had a great impact of using Internet of Things in their daily life. You can see when initially smartphones were developed, the users were only few. Later on, it increased, still further, it increased, and further, it increased. So, here also, when you go with respect to the IoT, also, as we have discussed in the beginning, initially, when IoT came into the existence, it was used only with respect to checking mail, web services, e-commerce, and then rapidly it acquired the day-to-day activities. So in each and every field, in each and every area, we see the IoT, that is the things that is involved in internet. So we can see over the span of time from 2003 to 2020, there is a wide development or usage of the things per person, or we can also tell it as there was a use there was a huge usage of smart objects with respect to IoT. So one of the impact of IoT is nothing but connected roads. So Google developed the self-driving car with the help of IoT. Here there is in the Google self-driving car, there is no need of any human being to drive the car. We are going to use a basic sensor which will be present inside the cars. It monitors the oil pressure, tire pressure, temperature and other operating conditions and provide the data around the core car functionality. Because of this sensors and data collected, it makes the car for the movement. And when we talk about IoT impact with respect to connected roadways, there were different challenges of safety and mobility. Even though the self-driving car was introduced, the main challenge is nothing but the safety. 5.6 million crashes in 2012, 33,000 faulties. It means there were a huge. When initially the IoT came into existence, obviously each and every people think about try to reduce the manpower. So that means the main idea is to cut short the manpower and to include most of the technology. So in the car also they try to instead of using the driver that means human being, they wanted a self-driving car. Sometimes what data they have collected, it might mislead us and then it might result in the car that is the failure, or it might leads to the crash of the car. So the main important challenge is the safety, because there is huge investment with respect to that particular car which doesn't have a driver, that is self-driving car. Along with that, when self-driving car has been used, no human being, like no driver will be present, other human beings will be present, and the car will be driving automatically. So it is the safety of human beings will be there in the self-driving car. So we have to take a proper measure and you have to collect the accurate data while developing the self-driving car. And mobility. So mobility is nothing but it's with respect to the connected vehicle. Mobility application will give drivers more informed decision which may reduce the traveling time. That means mobility means the time reduction. It should, whatever the self-driving car we are developing, it should take very less time to reach from source to the destination, and it should be environmental friendly. It should It should reduce the carbon dioxide emission, and it should be a green transportation choice. These are some of the challenges that we need to look into it when we are trying to do the connected roadways. One is mobility, one is safety, one is environment. Means whichever vehicle we are trying to develop with respect to IoT, it should be environmental friendly, and it should take less time, and it should provide proper safety. Next is, this is one of the example that you can see how exactly the self-driving car will be moving, how the data will be collected, how exactly the measures are taken, how the assistant has been provided for the self-driving car to avoid the collision with respect to the other cars when all the vehicles are coming in the same direction, when all the vehicles are meeting at some point of intersection. And this is how exactly the internal parts looks there. It has a wireless router for online entertainment, for mapping, dynamic rerouting, safety, security. It has connected sensor for transferring data. It has enabled proactive maintenance, fuel efficiency, and it has urban connectivity. It has reduced congestion, increased efficiency, safety. This is nothing but the same explanation there, and this is also the same explanation how the about the connected. So this is about the connected factory. Another important example we have seen about the connected roadways. Similarly, we have the connected, what we call as factories. In the connected factory is nothing but how exactly um, the IoT is having a huge impact on the products that is developed in the factory. Some of the main challenges that is faced by manufacturing any product in the factory is how to improve the how to accelerate the new product development, how to meet the customer needs, how to provide market opportunity, how to increase the plant production, how to increase the quality, how to upgrade the time, how to provide a securing for the product what has been developed, how to reduce the cost, how to increase the productivity, as well as what safety of the worker as well as the product which we are trying to develop, and how to check, how to control the products which has been developed, how to collect the data, how to analyze the data, how to uh, the what we call it as how to monitor the products that has been moved from one location to other location. So all these things are important challenges that we have to look into it when we go with respect to the connected factory. Next is, there are four industrial revolutions. First one is industry 1.0. It is in late 18th century, where basic machines powered by water and steam are part of production facility. Later in this early 20th century, it has industry 2.0, mass production, division of labor, electricity lead to the mass production facilities. And next, industry 3.0, electronics and control, production in automated further by electronics and IT. Industry 4.0, IT integration, that is today sensors with a new level of interconnectivity are integrated. So here today live we are using with respect to industry 4.2. This shows the different evolutions of industry there. But in today's life, we have moved from IoT to artificial intelligence, machine learning, data science. It is also another industrial revolution. And next we have the smart connected buildings. So the function of this building is to provide a good environment, comfortability, efficiency, and safety. And it should provide a physical security alarm like fire alarm, and then sensors should be used to detect the occupancy in the building. Lights should be off automatically when no one is there. That is the reason it is called a smart connected buildings. And sensors are used to control the heating, ventilation, air condition. Temperature sensors are used to spread throughout the building and are used to influence the building management to control the airflow into the room. And it is used for various and building automation systems provides a single management system for AWAC, lighting, alarm and detection system. So this is an example of how exactly the smart connected building has been used. You can see sensing, ventilation, light, backnet, coax, PBX is used for to connect different technologies, IP technology, IP cameras, building system on low voltage, building management system using low voltage POC. And this is what the basic architecture that you can see here. You can see the network infrastructure there with Cisco switches. It has light sensors, building AWAC, the AWAC for and IP video surveillance camera, Wi-Fi accessibility, building management, energy management, smart spaces and light control. And this is, you can see, LED ceiling with occupancy sensors which is going to capture the impact of LED ceiling is occupancy of sensor which is used to capture the temperature and which tells whether it should be in on state or in off state. And next we have another one smart creature. This is called as Roach. It is used to find the survivors if there is any natural disaster, if somebody has been lost, if something has happened, if any building has collapsed, if any human beings are unable to reach the survivors, then these sensors are placed to find out the people who are what we call who have been who are still survived but hidden under some buildings. Or it can also use it for this can be used for placed inside animals or insects to study their behaviors, to understand all these things. And next is the difference between IT and IoT. IT means it is comparison between IT and OT, operation technology and information technology. So we will see here in first criteria is operational focus in industrial OT network. Operation technology keeps on working for 24/7. In IT network, it manages computer data, employee communication system, secure system. And criteria is priority. In OT, in operation, it checks availability, integrity and security. Here also it checks the same thing, but first priority for information security is security, integrity and availability. And types of data in OT is monitoring, controlling, supervising data. Here it is voice, video, trans. In IT it is information. Information will be in terms of data, voice, video, like that. Security is control, physical access to data. Here device and user authenticate to the network. So this is about what the applications of IoT or impact of IoT, that is connected road, connected factories and the smart creatures.